Hi there, welcome to SS 5.1. We are describing and providing examples of edges and faces of 3D objects and sides of 2D objects that are parallel, intersecting, perpendicular, vertical, and horizontal. And you will see down here in the red, I've got your indicators, but basically what this outcome is focusing on is, do you know what these words mean? Do you know the difference between 3D and 2D? And don't you love my drawing? Okay, so indicator number 1 says, identify and describe examples of parallel, intersection, perpendicular, vertical, and horizontal lines, edges, and faces of 2D and 3D shapes. So you need to know what those words mean. And all of this, of course, they like it to be relevant to your life, which is important. B says you have to be able to sketch it. So you're going to watch me try and sketch. You know how that's going to go. An object that is relevant to yourself and be able to tell someone that it's parallel, it's intersecting, or it's perpendicular, vertical, or horizontal. And the last one, C, says you can describe your shape, whether that is by telling someone, you could describe it in writing, or you could just show someone physically through moving something what it means for a line or an edge or a face of a 2D or 3D shape to be parallel, intersecting, perpendicular, vertical, or horizontal. So on with the show. Let's find out what these words mean. Parallel. It is a train track. These two lines on the train track are never, ever, 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 ever going to meet. They are never going to meet because they are parallel. If they weren't parallel, at some point your train would come to a big crashing halt wherever the lines met. So these lines are not parallel. These ones are parallel. And you can see that in the word parallel, you have parallel lines. Look at that. The L's are parallel. They are never going to meet because they are the same distance from each other at every point along the way. Wherever you measure, they're always the same distance apart. Parallel. Here is an intersection. And the word intersection right here kind of looks like the word intersecting, and within that word you have the word intersect, and then you have this little word right here, sect, which comes from the word section. So they're all kind of related. Intersection, intersecting, intersect, and section. So at an intersection, that's where two roads meet. And so if you look at my red and blue line over here, the red line meets the blue line right at this orange point called the intersection. It doesn't need to be just two roads. You could have three roads. So here we have road N, road M, and road L, and they're all meeting at this point, which is P. So these lines intersect at point P. All right, moving on to perpendicular. Perpendicular means it's a 90-degree angle. It's a square. And this thing over here is actually called a carpenter's square. And he uses it to measure things like his deck to see if it's actually a 90-degree angle or not. So perpendicular lines, you can think of it as an L, you can think of it as a T, but wherever two lines meet at a 90-degree angle, you have something that is perpendicular. So when you're building your deck, he needs to make sure, he probably used a square right about there to make sure that his joist was 90 degrees to the house. Perpendicular. Vertical. Man, look at this guy. Look how high he can jump. And they measure it with these little thingamajiggers up there. I don't know what they're called, but he has to jump up there and knock them over, hit them to the side, and that measures how high he can actually jump. So he is jumping up to this guy's elbow. That's crazy. That's an impressive vertical. If you want to do vertical training, you should try skipping or jumping to see if you can hit the high mark on a spot in your living room or in your gym or whatever. So that is vertical. So remember this guy and his impressive vertical jump. Also, in your home, you might have something called vertical blinds that go up and down like these green things here. Quite lovely. So vertical blinds go up and down, just like this red line, up and down. So vertical just means that it's moving in a direction that is straight up or straight down. I mean, as straight as I can draw anyways. Now horizontal, this is a lovely picture of the horizon, and you can see the word horizon right there in that word. It just means the same direction as the horizon goes. So horizontal is from side to side, just like the horizon of this lovely canola field. Now, applications in real life. You could say that the dancer in red, her arms and legs are parallel to each other because they're the same distance all the way, like train tracks. So you could say this is parallel. Oh my gosh, I'm going to try and write on an angle. Watch this. P-A-R-A. Sorry about your ponytail there, girl. Yeah. Parallel. Yay! Did it. Okay, I'm not doing that anymore. So her arms and legs are parallel. This gal is wearing vertical striped pants. Now, just so you know, in the fashion world, vertical stripes are said to be slimming. So if she was wearing pants that went horizontal like this, she might look a little chunky, but that's okay. She looks lovely in her vertical striped pants. These are called horizontal bars, and you can tell the horizon goes this way and so do the bars. So that's an event in Olympic gymnastics, the horizontal bars. These gals over here are skiing and they're riding up the hill on a T-bar. Now a T-bar is a good example of something that is perpendicular. It has that 90-degree angle. Over here, there's a very complicated set of intersections. So if intersections amaze you, you could be a city planner and you could design intersections and how the lines are going to meet and how much space you're going to need to put your intersection in. When you look at it from an aerial view, an intersection is quite complicated, isn't it? So there you have it. We have parallel, vertical, horizontal, perpendicular, intersection. Those are all the words you need to know for this unit.